Dear students, today we are going to talk about use of transistor as as an amplifier. Well, what we do is here we see that sorry for interruption. Here we see that we have used this transistor as a common emitter configuration. In this what we have done is we have input terminal where we feed the signal which is to be amplified, means whose voltage is to be raised, and there is similar output terminal where we receive the raised voltage of signal which we have fed at the input circuit. Well, we have transistor. Here we are using NPN transistor. The arrow is indicating that it is for NPN transistor, and emitter is held common in with the input and the output circuit. We always forward bias the input circuit and reverse bias the output circuit, as we have learned in the discussion for transistor action previously. So here you see we have forward bias voltage, and if there is no signal applied, that means the input circuit is open. If we don't apply any signal over here, means this terminal is open. In that case the input circuit is not forward bias. Means if it is not forward bias, that means there will be very minimal collector current flowing due to the reverse bias applied in the output circuit. The input circuit will not help in making the current flow through the collector, because we have open circuit in the input, and therefore in that case the collector current will be very minimal. It will be only due to reverse bias effect, and the current in reverse bias case, unless it is at the breakdown voltage, this current is very negligible, and therefore the potential drop across the collector will be nearly equal to the applied voltage, reverse bias voltage VEC, means potential which is given by this combination of battery which is providing the reverse biasing of the output circuit, and therefore we have the output voltage will be of course high and nearly equal to EC, but no signal will be obtained in the output circuit. Now we consider that now we have applied the input signal, means the input circuit is now complete, and some varying voltage is applied as an input signal to this junction. And then in that case we have two situations. One is the situation in which the wave is having positive half cycle, means we are considering this part of the wave, and then during the positive half cycle you see the forward bias is supported by this positive half cycle of the signal wave, and therefore the forward bias will be effectively increased at the input, and as a result the emitter current IE will become very large, and if that is large, the collector current will be also very large, because we have the relation emitter current is equal to collector current plus base current, and therefore collector current becomes high, and as the collector current becomes high, the potential at the collector reaching the collector will be given by the relation VC is equal to EC minus ICRL. This is the potential drop across the load, and that will be the deduction from this voltage applied reverse bias voltage VEC, which is able to reach the collector, and therefore the potential across the collector, the potential across the collector will be reduced, and that means this output voltage will be on the negative side of the wave, and of course the voltage will be raised, but it will be in opposite phase as compared to the input signal. Here you see, while the input signal is on the positive side, the output signal is on the negative side, and so they are in opposite phase. Now we consider the yet another situation, that is, we consider the second half cycle of the input signal. What happens in this case, while for the negative half cycle of the input signal, the forward, it opposes this signal voltage will now oppose the forward biasing effect, and so the effective forward bias across the base and emitter junction will be reduced, and once it is reduced, the emitter current will be reduced because you see the forward bias is reduced, and once this emitter current is reduced, we will have lower value of collector current, and once this lower value of collector current is there, we will have the higher value of collector voltage, because IC is now reduced, so this product will be less, and so less deduction from this voltage VEC, and therefore the collector voltage will be increased, and thus so while in the previous case VC was decreased, but in this case now VC is increased, and therefore the output signal voltage will be on the positive half cycle, of course amplified, and so again you see that the output signal voltage is in opposite phase with the input signal voltage. So that means what you have seen, that in the common emitter transistor, the output signal, the output is always out of phase with the input signal voltage. Of course we can find the current, AC current gain and AC voltage gain as we have already discussed by this relation. It is AC current gain is the change in collector current to the corresponding change in base current, while we keep the collector emitter voltage constant. And also we have discussed how to find the AC voltage gain. It is the ratio of the current AC current gain into RL upon RI. RL is the output resistance and RI is the input resistance. So in the same fashion we can find the other parameters of the transistor, and this is how we keep getting the amplified voltage in the output with the help of a transistor. And here you see this reverse bias voltage is supplying the energy to do so, to do the amplification work. That's all for today. Thank you and have a nice day.